All right, number one, finding average rate of change. This is our first section of the year in calculus, and it's probably the easiest section of the year, which is good. So average rate of change is something you've already done. It's average slope, it's rise over run. It's basically just slope as you've learned it thus far. So this isn't really something new. The only thing that makes it kind of new is that we're going to be doing some things with it, and it's where calculus comes from. In this case, notably, where derivatives come from, our first section of calculus, which is finding the slope of things at specific points. And so we kind of use the idea of average rate of change, which is finding the slope between 2 points, and we zoom it way in and find the slope at 1 point. But for now, all we're doing is using 2 points and finding slope. So in the first problem on my website, which is I'm going to go over just to kind of explain how the problems work for this section, we're supposed to find the approximate solution, or the average rate of change, to this little guy means the derivative, which means the slope. So we're supposed to find the slope at -4. So average rate of change is just slope, and this little thingy means slope. Yeah. So first thing I did was choose -3 and -5 as my values. -4 is directly in between those, so if like this was some sort of graph and we started at -3 and we're like going this way with the graph, which is kind of weird. We start at 97, go down to 55, go down to 16, go down to 7, go back up to 28. So our thing looks something like this as we scoot along this graph. And so obviously our best slope to guess what's going on here is probably the average slope between these. Now this could be doing something crazy like this, in which case we messed up, but whatever. The problem asks us to find the approximate solution, not the exact. So we use -3 and -5. And then all we do is y2 minus y1 and equals x over x2 minus x1. So we do 97 minus 55 over, and the important part about this is that the 2's need to come first, and so I chose 97 as my y2, so -3 has to be my x2. So it has to come first, and we're going to subtract -5, and we get 42 over 2, or 21. And I call them unit thingies because I did not put any units in the problem, which Bookly would be very unhappy with me for. Alright, on to the next side. We have another problem here. Find the average rate of change. This one explicitly asks you to do that from 1 to 8. So here we don't have to determine our own interval. It's given to us. But we do need to find the values at 1 and at 8 because those are our y2 and y1s. So I plugged in 1 into this equation and got -4 because it's just 2 minus 6. And then I plugged in 8 and got 80 because it's 128 minus 48. And then you just do y2 minus y1. 80 minus a -4 is 84. And 8 minus 1 is 7. And you get 12 units. And that's really it. So I mean, the whole point of average rate of change and the reason we look at it in a class called calculus, which kind of is supposed to go above and beyond, is because if we look back at our graph here, say this thing actually did do some sort of wonky thing in between here, and we were like totally messing up with our slope, because this negative slope here doesn't at all match this like steep positive slope in the actual function. Well, if we like zoomed in and went only 0.1 to either side, so we had the values at -3.9, which is like here, and -4.1, which is like there, then the slope between those would be way more accurate. And kind of the idea for calculus is that we just keep zooming in. 0.1 ain't close enough. We're going to go to like 0.0001, and then we're going to go even farther. And that's why the next section we're going to do is limits. And that's kind of the big idea for average rate of change. Will this be on the AP test? Yeah, that's why we're assessing it. So, yeah, later.